Hello, in this video we're going to be looking at the aggregate expenditure model equilibrium. Now this is going to expand on what we've done in the two earlier sections, so if you haven't watched the videos about aggregate expenditures or marginal propensity to consume and save, definitely go back and watch those first. So equilibrium real GDP happens when aggregate expenditures equal real GDP. Now this kind of goes back to our circular flow model of the economy, where all of the money that households spend turn into money that companies have to then pay households for factors of production. So my company hires me, they give me a wage, I then use that money to buy products from the company. They then have more money to now pay me a wage to make more products, kind of an idea. So aggregate expenditures represents the spending side. And real GDP represents the production side, or the wages. So production and wages and spending. So we say there's an equilibrium when those two things are equal. We've got money going back and forth between households and businesses. On our graph, this is going to be any point where that aggregate expenditures function crosses the 45-degree line. So we've got our aggregate expenditures graph. So we've got aggregate expenditures here and real GDP on the bottom. And we're going to have an upward sloping line like this, as well as a 45-degree reference line. And that 45-degree line represents all points where aggregate expenditure equals real GDP. So anytime our function crosses that line, it tells you where the economy is in an equilibrium. Okay, so where that real GDP is equal to aggregate expenditures. Any change in autonomous spending or autonomous expenditures is going to shift that curve up or down. So autonomous expenditures means it's not determined by the level of real GDP. So a good portion of consumption is determined by real GDP because real GDP represents wages or disposable income. So consumers are definitely affected by their disposable income in determining how much they spend. But other things in our model, like government spending, for example, have nothing to do with the level of production. The government decides its budget, they plan what they're going to spend, and that is independent of tax revenues or income that's earned in the economy. So if we have an increase in government spending, governments increase their budget, that's going to shift this aggregate expenditure curve upward. A decrease in spending would shift it downward. And it's going to be a vertical increase by whatever amount that is. So if we say government spending is going up by $100, then this starting point where this line hits our y-axis is going to go up by 100. So let's say originally we started out at 300, government spending goes up by 100, and then that gives our new intercept gives us a new intercept of 400. It also gives us a new equilibrium point. So that new aggregate expenditure line crosses our 45-degree line somewhere else. And generally, it's going to be a lot more of an increase than just whatever that change in autonomous spending was. And that is because of that multiplier effect, which we talked about in the marginal propensity to consume and save video. So any shift is going to change our equilibrium to a new point. So any change in autonomous expenditures is going to give us a new equilibrium. Small changes in government spending or investment can have a much larger effect on the change in real GDP because of that multiplier effect. So real GDP represents total production in an entire year. And so a small initial change, government spends $100 more, but because that is spent multiple times throughout the year, it leads to a greater increase in total overall production in the economy. Autonomous expenditures are going to be changes in investment, changes in government spending, and changes in net exports. And the reason they're autonomous is because they're determined by something else. Okay, so in this model, aggregate expenditures is dependent on real GDP, right? Or it's determined by real GDP. Okay. Aggregate expenditures is determined by real GDP. But other things like investment, government spending, net exports, these things are determined by something else, right? Determined in another model. And so we're going to figure out what those numbers are. We're going to import them into our function and then have an upward sloping line that's only based on consumption, marginal propensity to consume, and disposable income. So here we have a table. This is figure 28.1 in your textbook. And this is looking at how the economy actually adjusts to that equilibrium real GDP. So here we see we have an equilibrium real GDP of 7,000. So this is consistent with the other graphs that we saw earlier in the chapter and in the other lecture video. So our aggregate expenditure line crosses that 45-degree line at 7,000. If for some reason we have a value of real GDP or aggregate expenditures that's different than 7,000, we would say the economy is in disequilibrium, and we're going to have some change to unplanned inventory that's then going to signal businesses to adjust. So let's say real GDP is $9,000. So that means our businesses have produced $9,000 worth of stuff. And in our model here, consumption is a function of real GDP. Planned investment is autonomous, or it's some predetermined amount that's going to stay the same, has nothing to do with the level of real GDP. And then we can see what happens with our aggregate expenditures and what happens to our unplanned investment. Now, this is going to be a simpler model. We cut out government expenditures and net exports. Let's skip ahead real quick. But you could see here in this example I'm going to have you do in just a couple slides, we have all of them. So we've got consumption, investment, government spending, and net exports. And all three of these, investment, government spending, and net exports, these are all autonomous, meaning they're going to be constant because they're not dependent on that level of Y or level of GDP. Okay, so adjusting to equilibrium. So we have 9,000 in real GDP. At that level, our consumption is 7,500 and our planned investment is 1,100. So spending in our economy is equal to 8,600. Okay, so these are not equal. Aggregate expenditures is less than real GDP. Okay, so our spending is less than our overall production. Meaning businesses have overproduced, right? They've got more stuff than they expected. So now we have this unplanned investment of $400. That means that there's $400 in extra inventory that we weren't expecting, that we didn't want. So our business wanted to have $1,100 in inventory, but instead they're ending up with $1,500 in inventory. So just like with our shirt example from a couple videos ago, they just have a bunch of extra shirts, right? Way more than they intended. So what's going to happen in the next period? They are going to reduce production, right? So they guessed wrong. They're not going to be able to sell that 9,000. So they need to reduce production, and they also have extra inventory. So they also need to reduce production to be able to sell that. Maybe they drop down to 8,000. Like, okay, let's do $1,000 less. When real GDP is 8,000, consumption also goes down because consumption is a function of real GDP. So in this case, our consumption goes down to 6,700. Planned investment stays the same at 1,100. When we add those two together, we see our aggregate expenditures is 7,800. Okay, so aggregate expenditures still less than real GDP. Okay, so now unplanned investment is $200. So they've got 200 extra. So their inventory is worth $1,300. If they lower it to 7,000, then we get consumption of 5,900, planned investment of 1,100, which equals 7,000 in aggregate expenditures. Great. Our unplanned investment is 0, right? We correctly predicted how much consumers were going to buy. We've got that inventory we want. We don't need to change anything about our production in our next time period. Let's say they dropped too low. Maybe 8,000 wasn't enough. They dropped down to 6,000. Now our consumption is going to be 5,100 plus that 1,100 in planned investment, and then we get aggregate expenditures of 6,200. That means unplanned investment is decreasing by 200. People came and bought more shirts than we were expecting. So instead of having 10 shirts on our rack, we only have 8, right? We've got less. So their planned investment was 1,100. They wanted 1,100 in inventory, but they actually ended up with only 900 in inventory. Their unplanned investment is negative, right? They sold more than they were expecting. What's going to happen in our next period? They're going to produce more, right? This is a signal that they need to make more stuff because they want $1,100 in inventory. So their customers are willing to buy more. They need to produce more to replenish that lost inventory. And so they're going to increase production. And so we say that this is a stable equilibrium because inventories are going to go up and down, which is going to signal businesses that they need to change their level of production. And if their inventory is exactly what they want it to be, then that means, great, we guessed correctly. We don't need to change production. We picked the right amount. Aggregate demand and aggregate expenditures are related, right? All of these things are made up of consumption and investment and government spending and net exports. Our aggregate demand curve tells us real GDP related to the price level. Our aggregate expenditures model tells us the real GDP and how it relates to total expenditures in the economy. So both of these graphs have real GDP on the bottom. The only thing different is what we're relating it to, the price level or the aggregate expenditures. Total demand versus total value of the finished product. Price levels actually reflected differently in each model. So our aggregate expenditures model up here on the top is not devoid of prices. Prices still play a role in this. It's just we can't see them on this graph. Aggregate expenditure model has some sort of fixed price for each curve. So for example, this lower line down here with point A, this has a price level or price index of 1.5. Our middle curve has a price index of 1, and our lower curve has a price index of 0.5. So each line, each aggregate expenditure model represents one fixed price, right, or one fixed price index. And so what the aggregate demand model does is it then takes that and it shows how GDP changes relative to the price level. And so anytime we have a shift in our curve, so we're going to say, let's draw our aggregate expenditures model at 1.5, price of 1.5, find that equilibrium point for the economy. That equilibrium point is then now plotted down here on this graph where we see real GDP and price level. So we say at a price level of 1.5, we have an equilibrium of $2,000. Then we draw our aggregate expenditures model with a price of 1. Find that equilibrium, which in this case is going to be 6,000, and then we plot that down here. So we see at a price level of 1, our equilibrium GDP is going to be 6,000. Then we draw an aggregate expenditure line where our price level is 0.5. We see that that would have an equilibrium point of 10,000, and we draw that down here. So price level of 0.5 gives us 10,000. So our aggregate demand curve is showing us all of the equilibrium points based on our aggregate expenditures model. Okay, so aggregate demand represents all possible points of equilibrium in our model. Okay, so point A on both of these graphs, the top one and the bottom one, represents a price level of 150 and an equilibrium of 2,000. Point B on both curves represents a price level of 100, right, or 1, and equilibrium GDP of 6,000. Point C on both of these graphs is representing that same price of 0.5 or 50, and a real GDP equilibrium of 10,000. So aggregate expenditures model shows you points of equilibrium and disequilibrium. If our businesses produce too much or too little, they need to adjust until they get back to that point of equilibrium. And then aggregate demand just shows you all of those points. Okay, so now it's going to be time for you to do a practice exercise. So get out all of your notes from this whole chapter, have your textbook out, get some paper and a pen, and you're going to test your knowledge to see if you know how to solve this. So we're going to have our model here. So we've got Y. This represents real GDP. We have consumption, investment, government spending, and net exports. You are going to add those up to get aggregate expenditures for each of these points here. Then first what you're going to do is you're going to draw a graph. So you're going to plot the aggregate expenditure curve and draw the 45-degree line. So you're going to take all the points of real GDP and all of these points you added up for aggregate expenditures, and you're going to plot them on a graph like this and draw a line. Number 2, you are going to find the intercept of aggregate expenditure. So this is going to be, what is the autonomous level of consumption, investment, government spending, and net export? So on your graph, it's going to be this point right here where it intercepts that y-axis. So we've got no disposable income. How much is our aggregate expenditures? You're also going to find the marginal propensity to consume. So when we have a change in income, what's our change in spending, right? So if we get $2,500 extra in income, how much extra consumption are we going to have? Okay, and then you're going to divide those and come up with that rate, okay? Like we saw in the I think it was the last video. Next, you're going to determine the equilibrium real GDP. This is where real GDP is equal to aggregate expenditures, where your curve crosses that 45-degree line. Part 4, this is going to get a little bit trickier. So now we're saying what's going to happen if net exports falls by $1,000. So that's going to be your curve shifting downward, right, by 1,000. So you're going to have to subtract 1,000 from your net exports and come up with new aggregate expenditure points in a new line. And then you're going to want to do for part 5, what is the value of the multiplier? So using that marginal propensity to consume, what is our multiplier in this economy? Okay, so pause the video now and work on this. This should take you a little bit of time. I would say at least 15 minutes, but for some of you, probably a lot longer than that, maybe 20 or 30 or more. If you are stuck on a particular point for more than a few minutes, you're not quite sure what to do, send me an email or stop by office hours and I will help get you unstuck. So pause this video, work on this for a bit, and then come back and we will go over the answers. Okay, so now that you've worked on this, this is what your graph should look like. So you should have aggregate expenditures on the y-axis and real GDP down there on the x-axis. Your first line, AE1, we should have an intercept here at 3,000, and you should have a real GDP of 7,500. Your second line, which is when net exports decreased, you should have an intercept of 2,000, and you should have a new real GDP of about 5,000. So hopefully your graph looks something like this. If you need to look at this a little bit longer, pause here. So for part 2, your intercept should be 3,000, which is the amount of aggregate expenditures. We just added up all of those lines, and that's going to be when real GDP is equal to 0. The slope of our curve is 0.6, which is going to be the same as that marginal propensity to consume. So we said, how much does consumption go up? The change in consumption, or the change in expenditures, divided by that change in income, or change in real GDP. So we're going to see that our income, or real GDP, went up by 2,500. Our spending went up by 1,500. And so when you divide those, you get 0.6. Number 3, equilibrium level of real GDP is 7,500. So that's where it intersects that line. Or if you were looking at your table where you filled out all of those points, you're going to have real GDP of 7,500, and then aggregate expenditures is also going to say 7,500 on that same line. Okay. Number 4, if we reduce exports by 1,000, it's going to shift that curve down. And your equilibrium real GDP is going to fall to $5,000. And then number 5, our multiplier is 2.5. So the change in spending, our total change in GDP dropped by $2,500, divided by that initial change is 1,000. Or if we were looking at marginal propensity to consume, you would say 1 divided by 1 minus 0.6, which is 1 divided by 0.4, which is equal to 2.5. All right, so if you have any questions about any of that, you would like to go through it in more detail, please let me know, send me a message in Canvas, or stop by office hours.